So we discussed Python's list when it comes to implementing a list ADT. Let's talk about linked lists. We can also use a singly or a doubly linked list to implement a list ADT. Again, if you need additional review on singly linked lists, doubly linked lists, these review materials are provided to you on Zybooks. Make sure to go through and review them. We assume you know your singly linked lists and doubly linked lists, because we do know that they have been covered in your prior programming language classes. Okay, so let's review singly linked lists. This is now a different data structure we are referring to. This is a different type of container. Python's list was able to store our elements with the ability of you to access through an index. There is no such a thing as index in a linked list. Each one of the elements are stored in a node. Node itself is an object. Node itself contains your information. So there is a part that contains the information you wish to store. Let's call that element. And there is a part in the node which addresses to the next node. Linked lists are self-referencing classes. They reference to themselves. That's how you establish the linked list structure. It's a concrete data structure. There are pros and cons of using a linked list versus a Python's list for any of the data structures that you're going to learn in this class. But we offer all this information to a software engineer, and it's a software engineer's decision to decide which one to go with and why. And that's what you're going to be learning in this class. Okay. So singly linked list is a concrete data structure. As I said, each structure is made of a node. Node contains the element and reference to the next node. Usually what we do have a pointer, not a C++ pointer. We use the term as pointer here loosely. A reference to the beginning of our list, and a lot of the times you will have a reference to the end of your list. So most of the time they are named as head and tail. And when your node does not point to anything, then it is considered as null. So you're seeing it, for example, A, B, C, D. These next is pointing to nothing. That is pretty much null. So if you wish to insert an element in a singly linked list to the beginning of the list, which is called inserting at the head, what you first do as a programmer is to instantiate a brand new node. That's what you're seeing as Baltimore is being instantiated. That's step number one. And then you change the reference of the head. Head is currently pointing to Rome, and you advance its reference to Baltimore. And that's how you add a brand new node to the beginning of your list. If you were able to remove from the beginning of your list, it is the same thing. But this time, you're going to reverse the operation. You first take care of the head, making sure head actually points to the next node before you delete the unwanted node. So you make sure head is pointing to Rome, and then let the garbage collection take care of the Baltimore as a deleted node. Okay? And if you wish to insert a new node to the tail, and say that in your linked list you have a reference to the head and the tail, you first create a brand new node. In this case, we created a brand new node with the element containing Zurich. And what we do is, after we instantiate the brand new node, we are ready to change the reference of the tail from Toronto to Zurich, and that's how you add it to the tail. Removing at the tail, this time, as I said, you're always going to be very careful. You change the address of the tail from Zurich to Toronto, and then you eliminate Zurich. So remember, when it comes to remove, you first change your references and then remove the node. Okay, so that's a singly linked list. Of course, there are also doubly linked lists. Doubly linked lists are highly preferred in the industry because of its runtime complexity. It's a very good runtime complexity that we will come to recognize, and you will get to see yourselves when you use a doubly linked list as your container to build more complicated data structures. So doubly linked lists work like this. You do again have an object called node, but your node has an access to the previous node as well as the next node. And your object you plan on storing is designated a spot in your node. Usually we visualize it as in the middle, and that's where you place your element. And that element could be anything. Like I said, it could be an integer, it could be string, it could be another object such as student or an employee object. So pretty much you have a link to the previous node, you have a link to the next node, and majority of the time when you implement doubly linked list, you will have again a reference to the beginning of your list, which is the head reference, and you will have a reference to the end of your list, which is the trailer. So if you wish to insert an element in a doubly linked list, you have a little bit more work to do than a singly linked list, because not only you're taking care of the next, you're also taking care of the previous. So in this successor and predecessor relationship, right? So if I were to insert a new node called Q and between P and its successor, so when I bring it in, first you have to instantiate a brand new node that contains the Q, which in this case is element X. So you instantiate that node, its previous reference is ready, its next is ready. So you make sure the element Q's previous is now pointing to P's, the node P's, and then element Q's next pointer is pointing to node C. While you're doing that, it looks a little bit crowded. What you're going to do is you're going to change P's next. Instead of pointing to the node with C, you're going to make sure that P's next is now going to point to the node where you have the letter X. Its next is now going to point to a Q where the element is X, and as well as C's previous, the node with the letter C, its previous now is going to point to the node with letter X. So you're changing the references. There's a lot of letters going on here, but don't let it get you all confused. Pretty much you have a node with an element B. You have a node that's coming in as brand new as element X. You have a node with an element C. So you make sure B's next is pointing to X, right? Element X. And X's next is pointing to element C. And while you're doing that, you make sure X's previous is pointing to element B, and X's next is pointing to element C. So if you don't want to talk about P's and Q's, you can just simply use the element to help your brain understand how the previous and the next works. If you do not like to look at the slides, rather see the simulation, check out in the Zybox. They will show you a good simulation of that as well. It should help you understand. Same story when it comes to deletion. So imagine that you're about to remove a node. Let's refer it with the element's name, D. Let's say that we are trying to remove D. So what are we going to do? Well, what is D's previous node? And what is D's next node? You need to take care of those references, correct? So you will make sure you identify, does D have a previous node? If yes, what should I do? Well, the previous node of D is the node C. So I want to make sure C's next is no longer pointing to element D. So we need to update that information. And what about D's next? Does D have a next node? If it does, then we will make sure that node's previous is no longer pointing to D, but it's pointing to C. And let the garbage collection take care of the unwanted node. That's pretty much how the singly and doubly linked lists work.